This lesson is going to be about fossil evidence of change. This is the first lesson in the evolution section. Go ahead and pause the video. I want you to write down what you know, what you want to find out, and at the end, we'll come back and we'll write down what we learned. So the central questions of the day: what are the similarities and differences between Earth's early environment and Earth's current environment? What is the typical sequence of events in fossilization? How are the different techniques of dating fossils used? And what are the major events on the geological timescale? Vocabulary that you should already know is extinction. If you don't remember that one from previous years, that's when an animal is no longer in existence. The whole species no longer exists. New vocabulary would be fossil, paleontologist, relative dating, law of superposition, radiometric dating, half-life, geological timescale, epoch, period, era, eon, Cambrian's explosion, KT boundary, and plate tectonics. So let's first talk about how early Earth was. So around 4.6 billion years ago, the Earth formed. So we had pieces coming in from all in outer space. They come together, they form the Earth. Eventually, gravity is going to pull all of the solid pieces to the center. So in the center of the Earth, it's very, very dense, and it gets less dense as it goes on the outside. About 5 million years ago, a solid crust, so the land that we have now, has formed. The atmosphere that we're looking at, it's containing no oxygen. It's high in water vapor, carbon dioxide, carbon monoxide, nitrogen, hydrogen, sulfur dioxide. It's not a very habitable environment, but it is a good environment for the beginnings and the creation of life. So let's talk about what a fossil is and how we get the fossil record. So a fossil is going to be a preserved organism. So it's preserved in sediment. At this point in history, about 99% of all species that have ever existed are extinct. But we've only seen a very small percentage of them because most organisms do not get fossilized. So most organisms do not get fossilized. We see very, very few organisms being fossilized. That's because most of the times they decompose before they're able to be fossilized. The previous slide, that was a video I posted on Schoology. So how they form, animal dies, sediment gets on top of it, and then the minerals start replacing where the organic pieces were, and it leaves behind an impression of the body that was there. So a paleontologist is a person who studies fossils. He's going to look at the different layers where they find fossils to help date them. So the deeper they find it, the older it is. The higher up it is, the newer it is. And that should make sense. Dies, sediment gets on it. Next one dies on top of it. You can't get underneath it. So that should make sense. And they also can take the rocks and they can date them. So relative dating, they can use radioactive elements and things like that to date them, the layers. So if we're looking here, layer A is newer than layer B. So if I ask you which organisms are the oldest, you would look down in F. Okay. All right, so radiometric dating. This one here, we're looking at the half-life of carbon-14. So a half-life, that is half the amount of time that it takes this element to decay. And that means to break down into another one. Carbon-14 will break down into nitrogen-14. So if we look at some rocks and they have 10% of the amount that they normally have, we can say that it's around 17,000 years old. So that's how that works. There's a brain pop. It's on Schoology, or no, it's on Connect Ed. You have to go to Connect Ed for that one. The geology timescale, that's going to be the expression of like each era of all the animals that have come into existence, and all of them when they go extinct. It's just a sequence of events. So some vocabulary that we need to know: an epoch, that's going to be our smallest amount of time. It's a little over 1 million years. A period is going to be composed of 2 or more epochs. It's around 10 million years. An era is going to be 2 or more periods. So that's 100 million years. And an eon, that's going to be our longest time period. That can be upwards of 1 billion years. So this is a really good video on the geological timescale. Go ahead and look at that one on Schoology as well. Briefly go through each one of them because the video covers them very well. The Precambrian, that's going to be the first one. It's the first 4 billion years of Earth's history. We're going to have our first life forms come about. We're going to get our atmosphere with oxygen. We'll talk about that one in our next lesson. We're going to have the first appearance of prokaryotes, eukaryotes, and small animals. It's going to be very, very rudimentary everything. Next, we're going to have the Paleozoic era. This is where we have the Cambrian explosion. The Cambrian explosion is where we have a massive amount of new organisms coming into existence. We're also going to have a mass extinction. 90% of all of the marine, so water-based organisms, are going to go extinct. And then we're going to branch off into the land. The Mesozoic era, this is the one that is most associated with dinosaurs. So the dinosaurs, they come about. They also have a mass extinction of the dinosaurs in this one. So if we're looking at the layers, we have what's called the KT boundary. That's going to be a huge buildup of iridium, which isn't found on Earth very much, but it's found in meteorites. So this supports the theory that a meteor hit the Earth and killed off all the dinosaurs. All right, so around this time, we're going to have the continents coming to where they're supposed to be. So this is going to give us our theory of plate tectonics. So we have these large plates of land that are going to move around on the surface of the Earth. So at first they were all together as one mass called Pangea. And then the plate tectonics, so these large land masses, slowly moved apart. And now we have our modern countries and land masses where they are. This is a good video about that. It shows the drift of everything. It shows you Pangea and how they all drifted apart. All right, the Cenozoic era. This is where mammals dominated. So we had the meteorite. It comes in, boom, hits, kills all the dinosaurs off. But the mammals at the time, they were really small, so they were able to survive. They were in the trees and they were able to get underground and things like that, so they survived. So now we have the rise of the mammals. They start evolving. Eventually, by the Neogene period, humans have arrived. All right, that was a lot real fast. Go back, watch it again. When you're done with that, go here, take the quiz. You need to log in, your student ID at students.fwisd.org. All right, good job. I'll see you guys later.